Hi everyone. In this video we are going to go through section 7.3, modeling with quadratic equations. You may recall quadratic equations from some high school math course in the past. We're going to see them in this section. We're going to use the quadratic formula to solve equations. We're going to graph quadratic equations and use a quadratic equation to model data. First, briefly, what is a quadratic equation? Well, it looks like this. Y equals ax squared plus bx plus c, where a cannot be 0 because then it wouldn't be quadratic. That is called a quadratic equation. As with linear equations in two variables, solutions are ordered pairs of numbers, and that's what we're going to look at in the first example. What does a solution look like? And here is that example. We have to determine whether the point 1, 2 is a solution to that quadratic equation. This is something that when I copied this over into the app that I use to create these videos, something a little weird happened. None of the exponents, or a lot of the exponents, don't look like exponents. So that first term there should be 2x squared. That'll happen in later examples too, and it's just a frustrating feature of the conversion process. To answer this question, we are going to substitute the 0.12 into that equation. What will help us is to label a little above the point x and a y so that we put the right number in the right location. All right, so y equals, so we're going to go 2 equals, and then 2 times x is 1 squared minus 3 times x is 1 again plus 5. All right, follow your order of operations. Square the 1 first. 1 times 1 is 1. 3 times 1 is 3 plus 5. Then 2 times 1 is 2. Minus 3 is negative 1. Add 5 is 4. So that says 2 equals 4, which is not the case. So that does not equal. 2 does not equal 4. So the point 1, 2 is not a solution. There's my answer there. All right, now visually, when we graph quadratic equations, they look like this thing called a parabola, which is this U-shaped blue there, or the upside down U that's red. The point there is called the vertex, and that parabola points upwards when a is positive. That makes my parabola open upward. Remember, a is the number in front of the x squared term, ax squared plus bx plus c. And when a is negative, the vertex, or the parabola opens downward. When we graph a parabola, or even investigate real-world problems involving parabolas, an important point to find is called the vertex. And the vertex of our parabola, we have a nice little formula for that. That should be ax squared again. We have a nice little formula to find the vertex, or the x-coordinate of the vertex, and it's negative b over 2a. So the b is the number that's in front of the x, and the a is in front of the x squared, and that formula will just allow us to easily find where the vertex is on our parabola. Then once we have that x-coordinate, we can substitute it back into the quadratic equation to find the y-coordinate. Now let's look at an example where we do just that. Here is my quadratic equation. Y equals 2x squared minus 4x plus 5, and I want to find the vertex of that graph. Okay, so the formula from the last slide, x equals negative b over 2a. All right, let me write down what my a and my b values are in this one. Here's the x squared term, the number that's in front of the x squared term. A is 2. And here is my x term. Notice how long my underlining is. That negative matters. The number that's in front of the x term, is negative 4. Okay, so substituting in, we have the negative from the formula, negative b over 2a, and then the b value is negative 4, and then it is over 2 times the a value is positive 2. All right, simplifying that, negative 4 is positive 4. Over 2 times 2 is 4. So that simplifies to 1. Okay, so our x-coordinate of our vertex, let me write it down over here, is 1. But we still have more work, a little bit more work. We have to find the y-coordinate. Okay, so I'm going to rewrite my quadratic equation down here. Y equals 2x squared minus 4x plus 5. Substituting my x value into that will allow me to find the y coordinate. Okay, so we simplify this. 1 squared is 1 times 2 is 2 minus 4 plus 5. 2 minus 4 is negative 2. Add 5 is positive 3. Okay, so our coordinate for our vertex, 1, 3. There we go. Now we get to the big old quadratic formula. So how do I solve a quadratic equation that is equal to 0? Or even if it's not equal to 0, the big step that I need to do is set it equal to 0. Okay, so notice this guy up here is equal to 0. When I have a quadratic that equals 0, the solutions are found using the quadratic formula. And I like the combined version at the bottom here. X equals negative b plus or minus the square root of b squared minus 4ac, that whole fraction or that whole expression over 2a. And that will allow us with one formula to solve a quadratic equation that's equal to 0. Now let's look at an example where we use that formula. X squared. There we go. All right, so as with the previous example, one thing that will really help you is to write down what the values of a, b, and c are. A is the number in front of the x squared term, but I don't see a number there, which means a is equal to 1. B is the number in front of the x term. Notice I circled the sign also. So b is equal to 5. And c is the number that is by itself the constant term, and that is a negative 84. So I'm going to write down the quadratic formula first so you can see it again. X equals negative b plus or minus the square root of b squared minus 4ac, that whole big expression, over 2a. And now I need to plug in, substitute the values in the correct location. So that equals negative b is 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 84. Notice I'm putting all those terms in parentheses. That'll just help me to keep everything separate and not lose track of any signs or accidentally subtract instead of multiplying. So I suggest when you do that substitution, leave your parentheses there. Okay, and all of that is over 2 times 1. There it is. So that's the substitute step. Now we have the simplify step. Okay, so what are we going to get? Let's see. X equals, I like to draw the fraction bar and do the denominator first. Usually it's a pretty quick multiplication in the bottom. Up top, negative 5 plus or minus. Now let's look at what we have under the square root sign. 25 is 5 squared. And then in here, we have a minus right there and a negative right there. So that's going to flip and become addition. So 25 plus 4 times 84 times 1 is 336. And I add the 25 to that for my next step. Negative 5 plus or minus the square root of 361 over 2. All right, so this is something you should definitely be using your calculators to help you to simplify. Negative 5 plus or minus. Now the square root of 361 is 19. That has a nice square root. When you're doing your homework, just pay attention to whether, if you get an ugly square root, pay attention to how the problem tells you to round. Okay? All right, so negative 5. Plus or minus 19 over 2. Now the next step is I'm going to take and branch this off and represent my two solutions. So all along I've been writing that plus or minus. Now in this step I'm going to split apart the plus and the minus in. So this that sounded really dumb. So this becomes negative x equals negative 5 add 19 over 2 and x equals negative 5 subtract 19 over 2. And then we simplify each of these. Negative 5 add 19, 14 over 2, which is 7. And negative 5 minus 19 is negative 24 over 2, which gives me negative 12. Boom. All right, so we have two solutions to this big old giant problem. X equals negative 12 and x equals positive 7. There it is. Okay. On this next slide, we just get a little bit more detailed information about what is called the discriminant, and that is in the quadratic formula, the part that is underneath the square root sign. So there's negative b plus or minus the square root of b squared minus 4ac. Right? That's called the discriminant, so that's the name that we give it. And what it does is it tells us just a little bit of information about the solutions to that quadratic equation. If it's greater than 0, that tells us that we're going to have exactly two solutions that are different. That's what distinct means. They're different from each other. When it's equal to 0, we have only one solution to our quadratic equation. And then if it's ever less than 0, that means that we don't have any real number solutions to the equations, because the square root of a negative number, it's not defined as a real number. It's an imaginary number, not something we get into in this course. You may have heard of them in high school. That's cool if you did, but you don't need to worry about them in this course. But if you do get a negative, that's what it means. There's no real valued solutions. And where all of this leads is to the process of graphing a quadratic equation. And we have parts A through E for this problem. If you want to pause the video right now and read through them before I go through them, go ahead, but I'm not going to read them out loud for you, but pause if you want to. Okay, to answer part A, I'm going to rewrite my quadratic down here. It's y equals x squared minus 4x minus 12. And actually, before I get to part A, what will help us is to write down what is the value of A, B, and C. A is the number in front of x squared. There's no number there, so it's 1. B is the number in front of x. Keep the sign with it. B is negative 4. C is the number by itself, the constant term. Keep the sign with it, and it is negative 12. All right, so now to answer part A, is the parabola opening up or down? This is no work at all. It's only remembering that A equals 1, which is positive, means the parabola opens upward. If that had been a negative number, then that would mean the parabola would open downward. For part B, find the vertex. For that, I need a formula, negative b over 2a, and now I can substitute into that formula negative 4 over 2 times 1, positive 4 over 2 is 2. Remember, that's just the x coordinate, so I have more work to do. I need to know what is the y coordinate. So we're going to substitute back into my quadratic equation. Put the 2 in for x there, and put the 2 in for x there. Okay, when we simplify that, 2 squared is 4 minus 8 minus 12. That is, let's see, 4 minus 8 is negative 4, minus 12 is negative 16. So the coordinate for the vertex, 2 comma negative 16. Okay. Now part C, we're going to determine the number of solutions as its own step, and then solve the quadratic equation x squared minus 4x minus 12 equals 0. Okay. Part C only asks for the number of solutions, so for that, all I need is the discriminant, not the whole quadratic formula. What is the value of b squared minus 4ac? Okay, that's the discriminant. If I substitute in, negative 4 squared minus 4 times a is 1 times, parentheses, negative 12. All right, that is 16. When you square a negative number, the answer is positive. Plus 4 times 12 is 48. 16 and 48 is 56, 64. There we go, 64. So because that is positive, we're going to have two solutions. Okay, there we go. So lots of parts to this one. Hope you're sticking with me. Find the x and y intercepts of the graph. Okay, to do that, let me give myself some more space here. To find the x and y intercepts, I'm going to draw myself a little table, x and y. The x-intercept and y-intercept are when the other number is 0. Oh, and this is for part D. Okay, so what I mean by that is if I want to find the y-intercept, for example, that's when the value of x is 0. So I take my quadratic equation, which I forgot already, y equals x squared minus 4x minus 12. So let me rewrite it down here. X squared minus 4x minus 12. I'm going to take my quadratic equation and plug in 0 for x minus 12. And hey, that all simplifies nicely to negative 12. Y equals negative 12. So that is the y-intercept when x is equal to 0. And then you do the same thing. You set y equal to 0, the opposite thing. You set y equal to 0 to find the x-intercept. Okay, so 0 equals x squared minus 4x minus 12. And to solve that, we need the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Substitute in our a's, b's, and c's. B is negative 4 plus or minus the square root of negative 4 squared. 4 times a is 1, and c is negative 12. Boom. Okay, we're almost finished with this one. Over 2 times 1. All right, getting there. All of that we did earlier when we found the discriminant in part C, earlier like a minute ago. So we have x equals negative 4 plus or minus the square root of 64 over 2. Square root of 64 is 8. Plus or minus 8 over 2. Almost there. Two solutions. Whoops. Try that again. X equals negative 4 add 8 over 2, and x equals negative 4 subtract 8 over 2. The first answer is 2, and the second answer is negative 6. Okay, so 2 and negative 6 go in my table there. All right, let's zoom out, take a step back on this problem. Whoa, lots of work. Look at all that. Okay, so that's a whole big process. Okay, but what it leads to is giving us enough information to graph this quadratic equation. And that's the last step here. All right, so I'm going to move all that off to the side, leave it there. It's a little small, okay, but you can go back in the video if you want to look at any of it larger. And my last piece here is I want to draw. I'm going to sketch a graph. In my math lab, you'll use the graphing tool, but I'm going to sketch a graph by hand of this quadratic equation, and then when I flip to the next slide, you'll see a much prettier graph. What is my scale going to look like? Let's just go out to like 1, 2, 3, 4, 3, 4 on the x-axis, and on the y-axis, I know that I had a number somewhere back there that was like negative 12 for the y-intercept. So I'm going to go like 5, 10, and 15. Negative 15, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, so let me make some points here. The vertex, that was 2, negative 16, so that goes down there. The y-intercept was 0, negative 12. That goes right there. Now, the next step is to go to your x-intercepts. But in doing that, I just realized that I made a mistake. And rather than re-record it, which I could do and go backwards in my video, I might as well just point out to you what the mistake was, because it's one that is really easy to make, and students do it all the time, and I take off points all the time, and you can't take off points on my video. I guess you could dislike it, but why would you do that? So let me go and show you where my mistake was, and we'll fix it together. Okay, it was when I substituted in right here. The quadratic formula is negative b. Well, my b value is negative 4, so I should have put that negative 4 in parentheses with a negative sign in front of it, and I didn't, and I terribly ruined everything. But let's follow that mistake through. Okay, so that negative 4 should be a positive 4 here. It should be a positive 4 there. It should be a positive 4 there. And it should be a positive 4 there. And what that does to my two solutions, 4 plus 8 is 12 divided by 2 is 6. And 4 minus 8 is negative 4 divided by 2 is negative 2. So it actually flips the signs, which is kind of cool. So it should be 6 and negative 2 for the x-intercepts. Oh, you've lost all faith in your math professor. He made a mistake, but it happens. Okay, so let me put all that back on there. There we go. Now let's add those 2 points, now that they're correct. Negative 2 here and positive 6. I don't have that labeled, but we'll just draw 2 more tick marks. Positive 6 right there. And so with those 4 points, I can try to draw a halfway decent, oops, I missed. Let's try that again. With those 4 points, I can try to draw a halfway decent parabola that passes through them. There we go. That's not bad. All right. And there's my equation. Y equals x squared minus 4x minus 12. There it is. And if you want to look at it much neater, much cleaner, that's a much better graph. The one on the left has everything labeled. The one on the right is just, it has the points clearly labeled. It's a little bit, the axes look a little, are harder to see, but there's my origin right there, okay? When we model with quadratic equations, there's lots of scenarios, lots of real-world settings that follow a quadratic equation that look like a parabola when we start plotting the data. So this is just one scenario, one example here, and that involves the 4 stages after a video game or a movie are released, okay, in their life cycle. Stage 1, sales increase rapidly. Everyone wants to play. Stage 2, sales are still growing. They're still going to increase week to week, but not quite as fast as the early process. You know, a lot of people have already seen the movie or bought the video game, but there's still a few more stragglers that might be purchasing it. Stage 3, the product still selling, but now each week's sales are lower than the week before. And then stage 4, the market is saturated. Everybody's seen the movie. Sales are now dropping rapidly. Seen the movie or bought the video game. And what that scenario looks like is an inverted parabola. So we can model that real world setting, that real world scenario with a math problem, with a math equation, which is, well, that's what a lot of people's jobs are built on. Okay, that is the end of the video. Thank you very much for listening. Go do the homework that's in my math lab, and please let me know if you have questions on it. Have a great day.